Welcome to Software Defined Segmentation. It's a live case study that we want to share with you all. My name is Amit Singh, and I'm a TME with Cisco Validated, primarily focused on secure campus and branch solutions. Prior to this role, I spent with 5 years with Cisco IT, designing and deploying SD Access and SD-WAN solutions, also Thousand Eyes. And before that, I was with professional services, almost 8 to 10 years working with service provider customers. I'm a 3-cross CCI and lucky to maintain it for 10 years. By this time, probably all you know about this app, so you can find the session and join the discussion room. I have my colleague added there, but I'm from USA and he is also in US, so probably he'll be coming up by now. So he'll answer all the questions, but if that is not happening, then I'll make sure I'll stay back and answer all your questions. And this space is moderated till November 15th, so feel free to write questions. If you don't have any questions right now, by like Friday evening or something you have questions, please feel free to write. For our agenda, I'm going to first give you a glimpse of what our master case study environment looks like, and then we will take a deep dive into different component like ICE, Catalyst Center, Meraki Adaptive Policy, SD-WAN Manager. But you can understand that it is not possible to unpack everything in 90-minute session, right? So it's not going to be a product 101, but I'll be sticking to underlying theme, which is how you can enable segmentation in this kind of multi-domain environment. So by now you have a little bit idea what we are going to do. We are going to showcase how you can achieve segmentation in this multi-domain environment using Cisco ICE, because Cisco ICE is going to serve as centralized identity and security policy component. Case study environment. This is, we call it live reference architecture or master case study. This is just a quick snapshot or picture of our DMZ lab back in RTP US. And this is one row with 8 full stack rack. And this row is responsible for secure campus and WAN. We have another row that is focused on data center. So the reason I'm showing you this picture and the hardware and software platform, just to establish that is, we are not trying to do like a repo depot or lone gear kind of thing and prove a point that this is working. No, this is actual infrastructure that we are investing in hardware, software, and licensing, and we use this infrastructure day in, day out. Like I have a Meraki branch in my home. We have a lot of locations where we have redundant ISP connection and all those things. So these are real things. And pardon me for this this picture, but this picture is essential because this is our complete playfield for segmentation evaluation map. So this is not everything in MCS, but it is a snapshot of how we are doing segmentation in multi-domain environment. And if I had to zoom in, you can see we have 2 core locations, NYC and NNJ. There's a pair of 9500. And other representation that I'm showing it as a cloud, they are various type of networks, like data center network or traditional 3-tier network, Meraki network, SD-WAN network. Everything comes together and connects to the core. And within the core, we are just connecting it using a private connection to simulate Metro Ethernet kind of connectivity. Because if you are a real customer, probably that's how you will connect your core location. So with that, we are going to go to our first component, which is Identity Service Engine. And let me set up baseline. So it is mostly going to be a show and tell story. So I'm going to talk about what part using slides, and then we'll go to a demo where you will see how, and for each component we'll have individual demo, and finally we will stitch them together to have an end-to-end demo showing you how you can achieve segmentation in multi-domain environment. So before we go to this, software-defined segmentation, right? That's a keyword. So what is a software-defined segmentation? Software-defined segmentation, in my opinion, is a capability to make network-wide changes in your segmentation strategy without making any real design changes. So it's on the fly, it's self-optimizing. Here you can see we have ICE, which is sitting at the very core of multi-domain policy. The reason being, ICE has capability to integrate with SDA access, it can integrate with 3-tier network, and it can integrate with Meraki dashboard, even ACI. So the reason we have ICE at the core, because obviously it fosters hybrid deployment, it supports redundancy, you don't have to type policies at multiple places, but most importantly, it becomes single source of truth for all your policy management and security. So this slide is just for your reference, because if ICE is so crucial for our deployment, then how about scalability and availability? So if you are an ICE customer, you'll know that ICE can have multiple personas like PAN, MNT, PXGrid, PSN. So for high availability and scale, what you can do, you can have an active and standby for PAN, MNT, and PXGrid. For PSN, which is actually responsible for authentication, authorization, you can have multiple PSN sitting close to the user network, or you can use a load balancer and use that VIP as a PSN. So that's just for the FYI. Now, this is again a primer, because once you start building segmentation network, or if you are SDA customer, I would like to ask a quick show of hand, how many SDA customers are here? Yep. So SDA customer, everything is built, right? You are using workflow, but when you happen to log into the devices, you will see tons of CLI. And part of that is IBNS 2 style of configuration. So I thought it's a good idea to flash it here and just give you a primer perspective here. You'll see we are in IBNS 2.0 style of configuration, we have 3 components: control policy, control class map, service template. So what happened in control policy? Device or your switch detects some kind of event, and then based on that event, it matches a class. And the class match can be like authentication type, authentication method, and once the class match happen, we have an action. Action is like authenticate using .1x and etc. Service template give you a capability to assign subscriber per session, ACL, and other parameters. So basically what you do, you build your policy map, and then what you can do, you can assign this policy map to the physical interface directly, but IBNS 2.0 style of configuration is already bloated. So what we are doing, we are using a source template. And this is a quick snippet of IBNS 2.0 style of configuration, and SDA customers might relate to it because you will see these policy map on your edge switches. So what you can do, you can apply this service policy to the source template and have other .1x parameter part of source template, and then you go ahead and apply it to the physical interface. So that's the way you are building your IBNS 2.0 style of configuration, which helps you with 802.1x configuration. Again, this is a little busy slide, and I have turned off the animation to save some time. So this is what is happening here. Let me break it down. You can see we have a subject, radius client, and radius server, previously known as supplicant, authenticator, and authentication server. That is our radius or ICE server. So what is happening here? A user comes online and it sends service request to authenticator, which is switch, and then switch relays it to radius. So on the left side we have EAP, and on the right side between authenticator and authentication server we have radius. So we have EAP messages that is getting mapped to radius servers, And once Radius authenticate user, it can also apply authorization as a part of authorization result. Throughout the life of this session, authenticator, that is our switch, keeps on sending accounting information back to Radius. So that is one way of authenticating your client, that is .1x. Here you can see we have another way of authenticating our client, which is MAC authentication bypass. And why we are doing MAC authentication bypass? Because for some users like printer or some devices, there are no special piece of software available. The supplicant is not available. In that case, what you can do? You can use MAB to authenticate your user and still apply authorization profiles. This is a snippet of authentication success. You can see I have a user connecting as NNJ202 client 21, and once it connects, it hit authentication policy. Once authentication is successful, it gets some parameters like VLAN, security group, and all those things get pushed to the user session using CTS AV pair. So this is all about like simple authentication and authorization that our ICE as a NAC used to do all the time, right? What you can do, you can assign a dynamic VLAN as a part of authorization. You can also push downloadable ACL, that means on demand, on subscriber session, you can put ACLs. But what we are interested in, security group tag. ICE can also allow you to push security group tag as a part of authentication and authorization. With that, we are going to the main part of the session, which is security group tag. So what is security group tag? Security group tag, as you can see in this representation, it's literally a 2-byte or 16-bit value that is encoded into Cisco metadata header. And Cisco metadata header is essentially 8-byte encapsulation. Out of that, 16-bit is SGT, and SGT gives you a literal value, 2 to the power 16, that is 65K value, literal value it gives you. So what you can do with that 60K, 65K values, you can assign a role, like you can have your employee number 4, your contractor number 5, and so on. So that's what you can do with SGT. And just before that, we have discussed the different way of classification, .1x classification, MAP classification, and here you can see we have 3 steps for Cisco TrustSec lifecycle: classification, propagation, and enforcement. And I have given you a little bit of teaser or primer about classification, how this classification happens. 2 of the dynamic classification we already discussed is a MAB and .1x, but that's not all. If your device is not supported for .1x, what you can do? You can also use static classification. That means you can have your VLAN assigned to, bear with me, yes. So you can have a L3 interface assigned to SGT. You can have a static IP to SGT mapping. You can assign a SGT to one VLAN, or you can assign SGT to one subnet. So there are multiple ways you can assign SGTs based on what kind of infrastructure you have. Okay. So you may be wondering that if there are multiple ways of assigning SGTs, then what is the tiebreaker scenario here, or what is the priority? Because one device or one user may have multiple SGT assignment. So here I'm listing all the SGT binding priorities from top to bottom, like it is 1 to 7, 7 being the highest versus 1 is the lowest. So I'm not going to read everything, but you can see the local, that is the authentication, what we just discussed. .1x authentication, MAB authentication. If your client is discovered with that, you are going to see local as your SGT priority binding. Then we have SXP, which is a control plane protocol, and we are going to talk about that in a moment. So these are the multiple SGT binding, and this slide is very interesting because it is hard to replicate all type of SGT binding in your environment, and luckily one of my colleague happened to capture that. So I thought it's a good idea to flash it here. You can see show CTS role-based SGT map all, and look at the column source where you can see all the bindings what we just discussed. In case of, okay, now we are moving on to trust-sec propagation. So first part is classification. For the trust-sec journey, the second is propagation. Within CTS environment, for example, if you have only one switch, it's fine. You can tag your traffic and probably you can go ahead and do enforcement also. But our networks are never one single switch, right? It's always distributed. So in that case, you need a way or a means to propagate your SGTs, what we just tag our traffic. For that, we have two methods, data plane or inline tagging and control plane tagging. Data plane tagging happens in hardware. That means one of the prerequisites is the hardware must know or support SGTs. It should understand SGTs. All the newer versions of Catalyst and MS390, all those hardwares, they are SGT capables. So here you can see we have an employee coming up and it get classified, get a tag. That tag is inserted right into layer 2 frame and that is sent in the wire to the egress. So that is about inline tagging. But it's not always simple, right? You don't have a direct connection. What if you have a WAN type of scenario or you are using some kind of a VPN network? That means IPsec, DMVPN and GET VPN. So inline tagging for that is also supported. Our IPsec or DMVPN configuration is intelligent enough to understand about SGT and can do the encapsulation. And I'll show you a snippet of that in a moment. The second option for propagation is control plane propagation. But let's understand why it is needed. Here you can see in this picture, we have switch 1 and switch 2, but in between we have something like a legacy or something, and that doesn't understand CMD or CMD metadata. So in that case, our SGT flow is broken. So to have SGT flow end-to-end, what we can do, we can create a SXP pair between switch 1 and switch 2 so that IP to SGT bindings, they are exchanged from one host to another host. A little bit more about SGT. SGT is a server client protocol. It uses TCP port number 64999. And it has two personas, speakers and listener. Speaker is one who is actually advertising IP to SGT mappings versus listeners are only receiving or consuming that information. And then we are at SXP version 4. There are newer versions. The latest is SXP version 5. So what happened in this TCP exchange? First, the three-way handshake happens. And then SXP sends an open message where it is advertising that, hey, I'm supporting SXP version 4 versus another side can say, I'm supporting SXP version 5. So during open message, the negotiation happen and we come to a common version. It's a backward compatible. So if you have 4 and 5, they will agree on 4. Once that agreement happens, then SXP update, SXP send an update where it advertise all the IP to SGT mapping. So now we know that we can use SXP to advertise IP to SGT mapping, but don't you think like it's too much of overhead to go to a central place, in this case ICE, and hard code all the IP to SGT, like 1.1.1.1 is SGT number 5 versus 2.2.2 is SGT number 10. It's kind of like an administrative nightmare. So luckily that's not the case. We have a knob where you can see publish SXP binding on PX grid and add radius mapping into SXP SGT mapping. So you don't have to create IP to SGT binding statically. Whatever we are learning from .1x, another thing, they can be translated into IP to SGT binding by ICE automatically, and it can share over IP to IP SGT over SXP. So here I'm going to show you a snippet, like a CLI. I'm a CLI junkie. I like to see things in action and under the hood. So this is a simple configuration for CTS. Without going too much into detail, what I want to highlight is CTS SXP connection peer. So you need to mention a peer. What is the other side of peer? Password, you can use a default or global password, and you need to specify what is my local mode. Local mode here is a listener because it's a configuration on switch. And this is the validation. So CTS SXP connection. The point to note here is connection status, which says on, and connection version, that is 4. Another thing is, it seldom happens when you have SXP peering between one private network where there is no restriction or firewall. So make sure when you are doing SXP, the port number 64999 is allowed. Otherwise, TCP handshake will be blocked and the peering will never come up. This is just, I learned a hard way once, so I thought, okay, let me put it here. Now, so we know about TrustSec classification, propagation. The final piece is enforcement. Here, my employee comes online and it is trying to access the IoT camera. So the question is, where does enforcement happens? Does it happen here very close to employee, or it happens in between, or it happens close to the camera, right? So for enforcement to happen, it must meet 4 criteria. The first one is switch or the device must know source IP to SGT binding. And how you can know that? When you discover or authenticate a client, you know that I have a client, it has this IP address, and we got this SGT binding for that. So the classification. Then it should know, or it must know destination IP to SGT mapping. That also it should know. Platform and VLAN has enforcement enable. So you must go ahead and say you may have multiple VLAN, and then you must say that or declare that these VLAN need enforcement. And also you need to enable it globally, which I think is redundant, but it is a critical piece of configuration. And last but not least, a policy must be downloaded from ICE. So here in this case, sorry about that. Yes, here in this case, as you can see, we have all the platform configured for layer 3 and layer 2 interfaces. And if I happen to enable propagation between all these links throughout the switch, what do you think where enforcement is going to happen? Yes, so it's a ingress tagging and egress enforcement. So you're totally right, because once this traffic hits the last node, it will have source to IP SGT mapping seen from incoming traffic. It will have IP to destination mapping because the client is locally connected. And on top of that, I'm going to go ahead and say CTS role-based enforcement for so-and-so VLAN. With that, enforcement will happen at the last. So this is a little bit extra detail, how the policy enforcement, the 4th criteria, what we discussed, that policy must be downloaded, how that is happening. So TrustSec policy acquisition, how the policy get pushed to the switch itself. For that, what you need to do, you need to create or configure your switch a TrustSec server. Switch should know who is my TrustSec server, in this case, ICE. And also you need to define CTS credentials that is similar as ICE. So with CTS credential, what is going to happen? The switch will create a secured tunnel back to ICE, and this is a pack-based tunnel. You can see CTS pack, so that means a pack certificate is pushed to my NAD itself, and now I have built a secure tunnel, and using that secure tunnel, we are going to fetch all the CTS environmental data. So CTS environmental data, you can see one side I'm showing all the ICE environmental data, and the same data is available on my switch because we have built that tunnel and we have enabled the enforcement globally. That's why it is all coming back to my switch. So this is how policy acquisition happens. You can see show CTS role-based permission. All my SG-ACLs get downloaded from ICE back to my switch. And as a part of that policy show access list, you can see I have a SG-ACL, role-based ACL that get downloaded to my switch. And finally, I'm showing you the enforcement part, which is show CTS role-based encounter. Here you can see from 13, which is SGT value, to 8, hardware denied. So we are denying SGT 13 to SGT 8 communication actively using SG-ACL, and that you can see in hardware deny. Finally, now we know classification, propagation, and enforcement. Let's see how it is happening. On the right side, my development server and production server comes online, and we are doing static classification here. And on left side, my employee comes online, and it authenticates itself as a dynamic classification. As a result, my production server and employee, they both have SGTs. Now we have some means of propagation already available, whether inline or control plane. So network is enabled for propagation. Then if employee want to access my production server, based on the policy, you can see employee is allowed to go to production server versus employee trying to access development server, that is actively shut down. Now here I'm going to show you, I mentioned right that there are multiple ways you can do inline tagging, and one of the way is having the SGT value encoded right into layer 2 frame. Here you can see we have CMD types, Cisco metadata, and within Cisco metadata, this is SGT5, the value is encoded in layer 2 frame. You can also do GRE tunneling. GRE is like broad enough or gracious enough to not care about what is inside the packet, and it simply encapsulates that. So within GRE is also possible. And then we have VXLAN group-based policy object, or VXLAN GPO. So for SDA customer, this will rings the bell, because within SDA access, we are doing VXLAN for our data plane. So SGT values are encoded as a part of VXLAN header within GPO. You can also do plain IPsec, like point-to-point, site-to-site VPN, and SGT value can be preserved, but it is not shown here. It is part of encrypted payload. Yes, please. Right. Right. Yes. So let me repeat that question for audience. The question is, why in SDA access the enforcement is happening at the egress? Egress, right? Yes. No. I think when you say TLOC, you are meaning you are trying to say map server, right? Because TLOCs are the edges where exactly. So map server essentially doesn't have any visibility about policy. The policy is residing on either on ICE or on Catalyst Manager. So map server only tells you that, okay, where is this EID? And it has the EID to RLOC mapping, so it points you to that RLOC. Mapping server doesn't have information about SG-ACL, unfortunately. All right, with that, we are at our first demo, that is ICE TrustSec demo. Here the expectation is I'm going to show you a ICE version, and this is 3.3. We have upgraded it to 3.4 recently, and this is a all-in-one persona. That means it's a standalone server with all-in persona built in. I'm going to show you some preset about the ICE, especially at the TrustSec portion. So if you go to Work Center, TrustSec, this is our playfield. and it has a nice overview of that, especially this dashboard. If you have SGT deployment, this is a pre-built dashboard that is highly underutilized. So I just wanted to flash it here. You can go to a TrustSec dashboard and see what's going on within your network if you are already doing SGTs. So you have all the live log and etc. Then we go to settings, and these settings comes to picture when you start creating your policy. So you can say IP to SGT mapping, how you want to create your mapping, all those things. TrustSec matrix settings, ICE give you an option to have multi-tenancy. That means you can have multiple matrices for policy. However, we are not doing that. But if you want to do so, you have an option here. Like work process setting, I'm sticking to a single matrix. That means all the NADs, they are going to refer only one matrix. But you can change that setting. And especially the SXP part, here you can see whatever we are learning from radius session, we are going to advertise it as IP to SGT binding. Then within SXP, we have some reporting and all those things. So I'm going a little fast in demo. Don't worry about that. These demos will be available in WebEx Team Room. You can go and watch that again. So with that presets, now let's go to the TrustSec part. And here you can see just the way we declared the CTS server there, we have created the CTS server, matching CTS server on ICE. This is my TrustSec server. And most of the time, especially in SDA environment, these are all automated, so you really don't have to worry about it. But the point here is, you can do SGT even if you have a simple legacy or traditional 3-tier network. So this is typical authentication and authorization. I'm using a default authentication set. That means .1x, MAB, and default. And then we have some authorization profile where I have my rule, different conditions, authorization profile. And as a part of authorization, I'm also passing security group tagging. So here is one of the example where my employee is authenticating using .1x, and we are assigning a tag called HR user. So authentication, authorization, and let me show you one of the MAB authentication so that we can look at authorization profile. Authorization profile. So once authentication happens, it will refer to an authorization profile, and the point I'm trying to highlight here is, as a part of authorization profile, you can pass on attribute like what is the dynamic VLAN? Do you want to pass on any dynamic ACL, DACL? All those things you can encode here. As you can see, I'm sending a dynamic ACL, employee ACL, and I'm parking them in a VLAN, named VLAN called employee VLAN. This is, and all these encodings, they are sent to the NAD or switch using CTS radius AV pair. And if you are wondering what is my dynamic ACL looks like, it's pretty simple. That means host can access anything but 8.8.8. So that's about AAA and authentication, authorization, and accounting. I'll show you one quick output. Here you can see one of my client came up and authenticated. So we have authentication success, match the rule .1x, and upon authentication, we have authorization result, which is .1x employee, and then which switch it is going to, and all those information you can see here. And everything has passed using Cisco AV pair. So we have a security group of 4 assigned to my employee. All right, now we are going to look at SXP configuration at ICE side, because we are going to use SXP when we go to our SD-WAN segment. So here I'm going to show you how to create SXP peer, and how you can create IP to SGT binding and map them to your advertisement. So you can go ahead and create a security group. Like I'm trying to create a security group, and I'm using the preset that I let ICE to decide what will be the hex or decimal value for that SGT. So we have all our security groups here. Then for IP to SGT mapping, here you can go ahead and create a manual IP to SGT mapping, as I alluded about that before, but it is not very efficient. But if you want, you can do that. You can hard code an IP address to an SGT. And we will talk about SXP domain in a moment. So this is how you can create IP to SGT bindings. But there is another efficient way to do IP to SGT binding. That means you can create a group. That means you can create a bucket with the values that what will be the source tag, what will be the domain, and etc. And then you can start attaching your IP addresses to that group. So that is another way to create IP to SGT bindings. Because if you have thousands of IP to SGTs and you don't want to advertise them all to one peer or listener, you can group them in multiple domains and then use those domains to create your peering. So here you can see I'm creating another IP to SGT mapping, but this time I'm adding them to a mapping group, and you can see 172.31, it is part of SGT mapping AWS workload. Now, how to create SXP peering? I have few peering already configured. Here you can see the status is on, peer role is listener, and SGT domain we are using is a default domain. So by default, it's a domain default, but you can create your own domain like 100, 200, and cloud, whatnot. So that's what you can do. All right, this is all about SXP. I'm going to move on, but you can watch this video in your time. This is how you can create. Right. So at this point of time, is there any questions about SXP, TrustSec propagation, etc.? Yes, please.
One quick question about SXP.
Mm-hmm.
Earlier you were saying authentication authorization was done with MD5 at the top.
So,
are there any alternatives? Because MD5 really isn't accepted as much of a thing anymore.
Yeah, that's right. Unfortunately, today in configuration, it's only MD5. Yes.
Okay. So
yeah, the simple.
authentication is essentially happening in plain text.
Say.
Authentication
Mm-hmm.
is essentially happening in plain text.
Yes, for SXP peering.
For
SXP peering. Yes.
And that's just the communication of tags across SXP, of the SGTs across SXP.
Yes. Right. Yes, sir. Any other questions? All right. So let's go to Catalyst Center. So, Catalyst Center or SDA Access, software-defined segmentation. And as I mentioned, this is not like a SDA Access 101 because SDA is so vast that it can take 4 hours to cover the high-level overview. So what I'm going to do, I'm going to just talk about few mandatory components, and then we will move on to the segmentation story. So SDA, as you know, it's a function of route, switch, and security that is orchestrated by a central orchestrator, in this case, Catalyst Center. And Catalyst Center does provide you workflows like design, provisioning, assurance, so that you can build your intent-based fabric without worrying about, CLI, configuration, and etc. So it has some out-of-box benefit, like you can get automation, you can upgrade your switches using the workflow, you will have insight and security and insight using assurance feature. So those are like some benefit with Catalyst Center itself. But when you take one step further, that means you're building a fabric. That is a different or paradigm shift because you are building your entire network using Catalyst Center, and the options what Catalyst Center is providing you in terms of control plane and data plane, that is, we will talk about that Lisp and VXLAN. So for SD access, there are certain mandatory component and optional component. From mandatory component perspective, the first one is Catalyst Center itself. You can have on-prem Catalyst Center, you can have a virtual Catalyst Center, or you can have Catalyst Center in cloud. And then ICE, though it is an optional component, but it is highly recommended for your fabric build. So if you're doing SD access, probably you should look into the ICE, because without ICE, micro segmentation is not possible. You can still create a fabric and have all the benefit, but if you want to go with a micro segmentation strategy, you must have an ICE. And that's why ICE becomes a mandatory component for our use case. Then within fabric, we have edge nodes, we have border nodes, we have control plane nodes, and optionally wireless also, because pretty much we all are doing wireless. So here, edge node is pretty simple. That's where your user and devices are being connected. Then we have the border node, which provide you the outside world connectivity or a connectivity to the other fabric, because you may be building multiple fabrics in multiple locations if you're a large customer. And then we have brain of this fabric, which is control plane nodes. And most of the time, you can have a collapse border and control plane. So it is not that you need a separate persona for that. Depend on scale. So please refer product documentation. Now, for micro-segmentation, as I alluded, ICE is a key requirement, and we must have a DNAC to ICE peering. And DNAC to ICE peering you can do from UI. And when you do that integration, here you can see I have taken a snapshot that what is happening here. Initiating connection, establishing trust, discovering node, and connecting to PX grid. So once you fill up the form for the peering, DNA Center automatically logs into the ICE and complete all the workflow. But this is just for your FYI that integration is not at only SSH level or HTTPS level. It is multi-level integration. And at the end, you will have a ICE available as a Radius server and a PX grid client. A little bit more about SD access fabric, because when we are talking about fabric, it's mandatory to understand the macro segmentation. And here you can see virtual network. We are using Lisp as our control plane, and Lisp gives you VNID, and VNID is essentially in routing world maps to a VRF. Edge node, border node, and fabric. Okay, let me just try to explain this Lisp function without going much into detail. So what is happening here, when you build your fabric and you assign your devices to a role or fabric role, that this is going to be my edge, this is going to be my border, this is going to be my control plane, you will see DNAC or Catalyst Center will push a lot of configuration, Lisp-related configuration to your devices. So essentially what is happening here is your devices are getting configured for Lisp, and every time a user connects, the edge node register that EID to the control plane. And when we have another user which is coming up and it wants to go to the other side, it queries the control node, and control node in turn reply with the RLOC, that this is the RLOC you need to go, and that's how the control plane is happening. But within the data plane, the actual packet is encapsulated into VXLAN. So we are not using Lisp as an encapsulation for data plane, we are using VXLAN as an encapsulation, and I'll show you that in a slide, upcoming slide. All right. With that, we are at macro and micro segmentation. And here you can see we have macro segmentation. That means when you build a fabric, you are creating your VNs, and you are creating a VN with the purpose that you know that everything within this VN, they are trusted. They can talk to each other. So this is by design. So two VNs by default, they cannot talk to each other. There should not be any communication between those two VNs. And that is our macro segmentation strategy. However, if you want to do something different, like in micro segmentation, look at the VN user. Now instead of one universal set, we have two roles assigned to the users. One is employee, one is contractor. And then you can allow or deny communication between them using security group tag and access contract. So no matter if they are part of the same VLAN, they share the IP address in the same subnet, you can control communication between them using SGACL, and that is essentially our micro segmentation capability within SD Access. I alluded to this before. So what is happening, with the Lisp control plane, a user verifies or come to know what is my destination RLOC or destination edge, and then traffic is encapsulated into VXLAN header with SGT information, and it goes to the egress node. Egress node in turn de-encapsulate that and look at the destination SGT. It already have source SGT, it already have destination SGT information, and since we have enforcement available, enable, the enforcement happens at the egress tunnel. This is a representation of data plane propagation, just like how I showed you that in inline tagging, we have SGT encoded into CMD. In case of VXLAN, you can see we have a VXLAN header, and within VXLAN header, we have group policy ID, that is our SGT value. And then we have VXLAN network identifier, that is the VNI, which comes from the Lisp world. And on top of that, please make a note that we have a UDP header, and UDP header is using destination port 4789. This is typical to VXLAN because VXLAN uses IP or MAC on top of UDP. Then we have SGACL. So I mentioned a couple of times that enforcement happens at the egress, and it happens with SGACL. So what is happening here? You can see we have Catalyst Center and we have Cisco ICE, where all the policies are defined. Then this policy get downloaded or pushed from ICE using that secure tunnel, the pack tunnel, what we discussed, right? One of the key benefit or key intelligence here in the Catalyst world is these switches, they look at what are the locally connected endpoint I have and what is their SGT. And then they go to ICE and only fetch the policies where they are themselves as a destination. So for example, you can have hundreds of SGACL or access contract where you have A is going to B, A is going to C, and so on. But my node who want to fetch the policy, he will look only the SGTs which is connected locally and fetch only the subset of the policy. So it's not that you are dumping all the SGACL to the end node. It is intelligently fetching the policies which is needed for its enforcement. Yes, sir.
I understand part of that's for the sake of scale, because you don't want every switch downloading every policy that's a problem to TCAN, etc. Are there concerns with scale when it comes to this? These are dynamic groups that can obviously get expansively large.
Yeah.
So are there concerns for scale for some of these policy sets when they get downloaded into the switch? And are there concerns when you start going, say, dual stack V4, V6, and how that might affect the scale since V6 ends up taking a lot more space as well?
But this role or identities, right, they are abstract. They are agnostic to IPv4 and IPv6.
But the egress switch, which makes the drop decision,
Okay.
it doesn't need the mapping from the SGT to the IP address in order to do the drop decision, or because the tags are there?
Yeah. No, it doesn't refer to IPSGT anymore. So it just refers the matrix and the SGACL downloaded, and yes. So that is, Yeah, that is actually one of the great benefits. So let me recap that question. So what happens if your switch is dual stack? That means you have IPv4 and IPv6. Do you need like different kind of mapping for them? The answer is no, because the SGACL is only looking at source and destination, comparing only source and destination. So you can have the same SGT assigned for an IPv4 and same SGT assigned for IPv6 also. So that's actually one of the advantage. So there are two things. It only downloaded the policy where it sees itself as a destination. So that's pretty efficient. And the another one is you can abstract IPv4 and IPv6. Going back to SDA, we talked about SD component or roles. So obviously when you build Fabric, it's not in isolation. You want to connect it to the outside world. And there are multiple ways you can connect it to the outside world. You can use IP-based transit, where your border give you a IPv4 connectivity. So like a vanilla IPv4 connectivity to the outside world. And if you have multiple fabrics and you still want to preserve your VXLAN and Lisp information, then probably you can do SD access transit. That means two fabrics connected together, and you are building SD access transit. So the fabric, so the traffic leaving the fabric, it's not decapsulated. It's still VXLAN and Lisp encapsulation. Then you may be a SD-WAN customer, so you can use SD-WAN as a transit, and SD-WAN is intelligent enough to preserve the SGTs. That's what I'm going to show you in one of the demos. So in our use case, we are doing a mix of both. We have SXP, as I showed you earlier, that we have two locations, NYC and NNJ, and they are connected as a private line. So we are doing SXP there, versus when we connect multiple domains like SD access to Meraki to BGP, EVPN, and whatnot, our switches are mostly inline capable. So we are doing static configuration, that is CTS manual policy static SGT2 trusted. That means when you do CTS manual on the physical interface, it is supported for, it enables the support for SGT tagging or propagation. And then on top of that, I'm creating a trustsec domain by saying policy static SGT2 trusted. That means if any traffic which is tagged hit this interface, please honor that tag or trust that tag. Don't override that tag. And if something hits which is not tagged, then go ahead and mark it with SGT2, because SGT2 is reserved for infrastructure purposes, and you don't want like unknown traffic flyby in your network. So we are going to tag it with SGT2. And now, just like how I showed you in non-fabric environment, what happened in fabric environment, same thing. We have authentication happen for camera, it get an SGT, and then we have Lightning and HVAC authenticated themselves, maybe .1x or MAB, whatnot, and they have an SGT available. We have SD access. It is enabled for propagation automatically. It is a part of workflow, so you don't have to do anything. And then you can see when my camera traverses the VXLAN overlay and try to access the Lightning and HVAC, it reaches the other edge node or remote locator, and here it get the policy is being referenced, and you can see we have our camera allowed for Lightning versus, oh, my bad, sorry about that. Yeah, my camera is allowed for Lightning versus it is blocked to access HVAC. Simple. The point being here is you don't have to think about propagation and etc. because it's all automated.
And this policy is pushed by the ICE?
Yes. So this policy is pushed by ICE because essentially this edge node, it is a part of trusted infrastructure. All right. With that, I'm going to show you the Catalyst Center demo. And within Catalyst Center demo, we are just going to familiarize ourselves with the fabric so that when we go to the final demo, you'll have understanding of what is in there. So the first thing is DNAC to ICE integration. So
when we configure the SXP, so then the peer IP is a firewall IP or either ICE?
So SXP,
Yeah, yeah, because we configure a source and destination, so definitely it will be the switch, and the peer IP will be the.
so whatever is your next SXP. So in this case, mostly you do SXP between a switch and ICE. So the peer IP will be the ICE IP address. Yeah, PSN.
For example, if I want to involve the firewall at a test sec, so then I will have to mention the peer as a firewall.
Yeah, you can obviously run a SXP peering between ICE and firewall. So with that, I'm going to show you the DNAC to ICE peering. You can see it's inactive, but here when you go to authentication server, it gives you a form which you need to put all the details like username and password. Make sure the ICE is available or resolvable for FQDN because there is a certification or trust is in picture. And once you do so, this is the server integration workflow. Now we'll move on to PX Grid. So for PX Grid, you don't have to do anything extra. You just need to complete this workflow, and you will see the ICE is available as Radius server. At the same time, ICE is also available as PX Grid. So our DNAC becomes PX Grid client. And for that, we'll go to ICE PX Grid. You can see we have total number of clients, and I'll show you what is happening with DNAC. Here you can see PX Grid client that ends in 670. That is nothing but our Catalyst Center or DNAC. That becomes PX Grid subscriber. So it can receive all the information, multiple information from ICE. And that's I'm going to show you next. So we have our Catalyst Center as a client, PX Grid client, connected to ICE, and it has subscribed to all this topic for contextual data like SGACL and so on. So these are like under the hood details that you should know.
When you add ICE to DNA Center, does it actively start making any changes within ICE, or is it just passively consuming information?
Yes, so PX Grid is a publisher and subscriber kind of relation, so it doesn't make any changes, it just consumes the topic informations. Yep. All right, so that's about DNAC and ICE peering. And as I mentioned, all this TrustSec domain, they are automated. When you create Fabric, that means you go to your AAA and add ICE as your NAD or AAA server, then you will see all the NADs or switches, they'll get AAA information automatically. All right, now I'll just quickly walk you through what is different here. Within policy analytics, you can see since I have peering, I have all the SGTs available from ICE. So all these SGTs, they are getting pulled from ICE. But policy, let me stop here, and you will see one of the key things, because this is our case study, right? It's not how you build a turnkey solution, but how we are doing that. That's what we want to share with you. So here you can see group-based policy access control is managed in Cisco Identity Service Engine. That is a conscious decision for our use case, that is multi-domain segmentation. So we want to make sure that all the policies are defined and governed at ICE. So this is what you can do. There is a knob available actually, and that's what I'm going to show you. So when you go to configuration, you can specifically define that Cisco Identity Service Engine is going to be owner of my group-based policies. So, and the next is pretty simple thing. This is our Fabric site. This is our Fabric infrastructure. We have 2 edge nodes to border and control plane nodes, and we are using IP transit for the handover. You can see we have two VNs, campus VN and guest VN, because obviously we don't want guests to talk to corporate users. So all the corporate users, they are part of campus VN, and these are the different VLANs that are mapped to. These are the different VLANs that are mapped to that VN, campus VN, and then we have a guest VN that is completely separated from campus end to end. And the last thing is we are doing a close authentication from day one. That means all the ports, they are configured for IBNS 2.0 style of configuration that we discussed in the beginning. So all the ports are .1x enabled, and you can see for each NAD, we have CTS credentials, and that happens automatically in SDA. You don't have to create your NAD and create TrustSec settings. So that is the power of automation and the workflow. All right, so let's move on to the next segment, which is Meraki Adaptive Policy. And as you can see, I didn't title it Meraki 101 or Meraki Overview because we wanted to focus only on one capability, Meraki Adaptive Policy. And Meraki Adaptive Policy is equivalent to Cisco TrustSec, what we do in traditional network or BGP EVPN network. Meraki Adaptive Policy, it utilizes inline security tagging. So here you can see we have same concept, TrustSec concept. User or endpoint comes up, get an SGT, and it is traversed throughout inline. So about that. So the change, here you can see Meraki and ICE together. So Meraki can do adaptive policy, that means classification, propagation, and enforcement by default, by its own. But what we are asking to change here is Meraki and ICE integration. You can see Meraki and ICE, they are integrating at REST API levels. That means all the egress policies, SGTs, they are being synced from ICE to Meraki dashboard. Also, now we have a new capability to define your AAA server org-wide as org-wide radius within Meraki. So the same ICE node what we are using, we can use it as a radius server. Point to note here, something is different from Catalyst versus Meraki is within Catalyst, you have pretty much unlimited or a good number of scale for CTS, but in Meraki, it's somewhat restricted. So you can see we have 60 SGTs, 3,600 policies, and so on. So please be aware and refer to the product documentation. Group-based policy. If you are a Meraki customer, you know that group-based policy is an amazing feature within Meraki. It helps you or allow you to assign per session settings, like per sessions, layer 3, layer 7, filtering, bandwidth restrictions, and all those things. And this group policy, when you do adaptive policy, you can still utilize group policy, and that's I'm going to show you next. This is about the propagation. So how the propagation is happening. We have propagation enabled at, if you're doing hub and spoke, you can see at spoke side, I'm saying peer SGT capable. You need to toggle this tab to enable propagation. So at spoke side, I'm saying peer SGT capable. And at the hub side also, you need to go and say peer SGT capable. And this is equivalent of saying CTS manual policy SGT2. So what about brownfield kind of environment where you have mix of network, because Meraki adaptive policy is highly hardware dependent, like MS390 and others only can support SGTs. So what if you have a mix of environment? Meraki network is intelligent enough to address that situation. And if there is a communication between two sites which are capable and non-capable, Meraki automatically strip off the header and the communication is seamless. So that is already available. Now, Let me show you Meraki adaptive policy demo. So we are logging into Meraki dashboard. And the first step is we are going to get the API key. And this API key is important for your Meraki to ICE integration. For this API key, you need to be an org admin. So go ahead, create an API key, download that. And then when you go to ICE TrustSec, you will see a new knob available which says Meraki integration. Go to that workflow, and then you can see there is a default connection name. I'm going to change that to make something relevant, MCS Meraki, and put that API key that you got from Meraki dashboard. Hit connect. Now, based on how many organization you are part of, it will show here, I'm part of one organization. So I'm going to select that, next, and then some parameters like how often you want to sync. I want to sync like every 12 minutes, that is the default. And then what are the SGTs and policies that you want to send to Meraki dashboard. That you need to do it manually. It's not a complete dump, so you can selectively pick what you want to send to the Meraki dashboard. So I have picked my SGTs. Then next, and this is a nice summary of what is the sync interval, what SGT you want to send, what SGACL, and all those things. Submit that form, and we have the connection established. Here you can see sync status is perfect. So we have 9 of 9 egress policy syncing, SGACL syncing, and whatever SGT you selected, they are all synced, and it says fully synced. That means all this information is available at Meraki dashboard. It's synced every 12 minutes, but it doesn't. You don't have to wait every 12 minutes. Suppose you added a new SGT and you want to sync immediately, then you can just go to your overview and say sync now. Sync status, you can say sync now. With that, you can see our egress policy came down to 8 and SGT 7 because we deselected one of that. So this is how you create Meraki to ICE integration. Now let's go to Meraki and verify whatever we are seeing at ICE side, if that is true, and what is the Meraki view. So you will go to Meraki, Meraki adaptive policy. Here you can see we have all the groups, policies, everything syncing from ICE database. Yes, all this custom ACL, that what we are sending. And finally, the network, because within Meraki, if you want to enable TrustSec, Meraki will give you an option that yes, this site has something available which can support SGT, so you can go ahead and enable adaptive policy. Now, for our demo, final demo, I'm going to create a radius server within Meraki, and this radius server is nothing but my ICE. So you can define a radius server globally or at org level, and then you can use that radius for individual networks or on individual switches. So this is how you can add a radius server, and you can see the IP address is my ICE IP address. So we have done two things. We have first created a ICE to Meraki integration so that we have all the policies and etc. available. And now we are adding our ICE as radius server so that the client in Meraki network can authenticate with my ICE, get the tag, and based on the tag, we can refer the policies which is coming from ICE. All right, these are like usual settings that you can apply. If it is a multi-host, it is a single host, and so on. Let me speed up a little bit here. And this is about the group policy. You can still use your group policy In this case, I'm saying wired map. And for this group policy, what do you need to do when you are in your ICE? You need to configure it as, you can see, so, jumping. You can see we have our group policy called as filter ID. So in this case, we call it filter ID. And the group policy name and filter ID name must match. So you can still use the Meraki good things while using Radius as your central server. All right, so let's move on to the next component, which is Catalyst SD-WAN Manager, data plane tagging. And this is a little different than what we discussed so far, like SDA and Meraki. So what is happening here? You know, SD-WAN is also SGT capable. That means it can understand SGT. But how we are doing that? We are doing inline SGT propagation. And you know, in SD-WAN world, we run a protocol called OMP. So how OMP can help us get SGT information? That's all I'm going to show you. So to enable SGT support, you need two tabs. The first one is for VPN 0, you need to make sure that CTS SGT propagation is enabled so that anything coming in VPN 0, it will honor the SGT values. And then for your service-side VPN, make sure the service-side VPN feature template has enabled SGT propagation, propagate, and trusted enabled so that the SGTs can make it to the service VPN. And things will clear when I'll show you the demo. And this demo is very comprehensive. So I'll show you the demo next. But before I play the demo, is there any question that I can answer?
Is this for the transit
Yeah. Yes, it is for transit, but at the same time, I'll show you in demo how you can leverage that if you have UTD container or some kind of like a security firewall. Yeah. So let's play the SD-WAN demo. SXP, first we are going to create SXP entries for our vSmart controllers. So I have two controllers, and as you can see, I have added them as my SXP peer. However, the status is off because this is not SXP-based advertisement. It is actually PX Grid. But one of the key requirement is your vSmart should be available as SXP peer. And the domain, please pay attention to the domain. Here you can see the domain what we are using. We are using domain as 100 or 200. The number should match your service-side VPN. So you know in SD-WAN world, you have service-side VPN where you assign it a number, that your SXP domain must match that. Now, within SD-WAN or Catalyst Manager, going to settings, integration management, you have to create this entry for the peering. So you can see identity service engine, I have a peering available, and I'm peering only for SGT. Let me go back and stop here once. Yes. So you can see feature subscription, we are only subscribing for security group tag, no SGACL. We want to get all the security group tag from control plane, and we want to make sure the data plane is available to support SGT as well. So this is the control plane part. ICE2, you can see all the SGTs are available. And to validate that we have a PX Grid connection, I went to ICE, and you can see we have our vSmarts available just like DNA Center or Catalyst Center. We have our vSmart available for PX Grid client. And they are listening to the binding called ICE SXP bindings. This is a peer pub and sub relationship. All right. So with the control plane available, let's look at the data plane part, which I showed you during the slide. So you need to enable CTS propagation in VPN 0. You need to enable CTS propagation in service-side VPN. And that's what we are going to do here. So I have a device template.
Selectability through the VPN 0?
Yes. All right, so this is what we are going to do. If I go to tunnel and TrustSec, you will see we have security group tag and everything enabled. Yes, under feature template.
It means OMP will establish, so then it can communicate with the ICE.
Yes. So let me just speed up here a little bit and show you things. Yes, this is for service-side VPN. No, this is not dcloud. This is our live reference architecture, but we welcome partners and customers to take a look if needed, if that helps. Yes. So here you can see we have, I'm just verifying things from CLI, the Boston Edge 1. It has SGTs available via OMP, and it has SGT available in service-side VPN. So once you have the SGTs available, what you can do? Generally, you want to do same thing like egress enforcement, but in this case, we have security firewall. So what I'm going to do, I'm going to create a security policy, attach that security policy to my device profile so that I can use SGTs or identity for my firewall rules. So that's one different, because we are only getting SGTs, we're not getting the egress policies, but you can still use tags like identity HR as a source and identity employee as destination and create your firewall policies. So this is a little bit different from regular what we discuss, but that's what about, this is what about Catalyst SD-WAN. So let's go to the final demo. And in this final demo, you can see I'm going to show you a quick demo how a client in Meraki side can talk to a client in SDA access side, and how we can control the communication using ICE egress policies. All right, that's going to be our final demo here. All right, here you can see we have a client 1053.180.5 at Meraki side, and it has an SGT applied using ICE SGT of 5 because it's an IoT machine. I'm going to speed up a little bit here. And then we have another client which is in 10.202 subnet, that is my SDA client. It has authenticated and got an SGT value from ICE. And that I'll show you here. It has an SGT value of 4. So we have a client with SGT value 5 at Meraki side. We have a client with SGT value 4 at SDA access side. And right now, there is no policy or no enforcement. That's why they can talk to each other freely. You can see that we have the bidirectional communication available here. So what is going on? The IoT machine, it is running an application on TCP port 3000, and you can see the SDA client can also access that TCP application. So everything is working. There is no restriction. And now let's go ahead and create an enforcement. So what I'm going to do, I'm going to create a SGACL or a policy that says that employee can connect to IoT, but it cannot connect to IoT on so and so port number. So that's the one policy I'm going to create. Right now you can see between employee and IoT there is no policy. So let's go ahead and create a policy plus access contract that blocks that communication, deny TCMP destination equivalent to port 3000. So we are going to select an employee as a source, destination is IoT, and block IoT dashboard as my access contract. With that, the policy will be available on ICE metrics. You can see block IoT dashboard that is available. We are going to push this to speed up a little bit because the preset is whenever we make some change, let's wait for some time. But if you want to speed up, you can just push the policy. So now let's try to access the application again. We have the policy in place, but is it working? Is it like enforcing? So let me test that. So policy is not working because we can still load the portal, right? 3000, though there is a policy. Any guesses why it is not working? Yep, good point, good point. So synchronize is 1 point for sure. So let's go ahead and check at Meraki side, policies. So let's go to ICE sync selection. Here you can see we created this new policy, but we never selected that, right? Because in Meraki side, it's not a blind dump because of the restriction, right? So every time you create a new policy, you need to sync selection. And once you do that, you can see the ICE to Meraki sync will increase. Now we have 6 egress policy, and it will make it to Meraki side. Policies, let me refresh that. And yep, so once we refresh, employee to IoT, custom permissions, and that is available now. So that policy is available, and now let's go back and check. We can have the ICMP reply available because we don't want to block ICMP. We want to block only certain application. So let me go ahead and verify that. Yes, you can see it's not loading anymore. Yep. So the policy is in effect. All right, the final piece I wanted to show you here is if you are thinking about starting with SGTs and you don't know where to start, Catalyst Center has something to offer. Within Catalyst Center, if you go to policy analytics here, you can see all the communication going on, like we have IoT to employee communication, those things you can visualize here. Destination, here you can see the same flow will be available that we have TCP traffic going on at port 3000. So you can use Catalyst Center as your starting point if you're thinking about you starting your SGT journey, and that's one feature that is available. I think I'm pretty much out of time here. So it was a lot to unpack within this short time, but if you are interested, I'm going to give you this 5 links that are nothing but it talks in detail about each and every domain. Like first one is a introduction of our MCS environment, how it looks like, how many BGP and IGP we are running, all those things. Then it talks about the 3-tier network. If you have traditional 3-tier network, how you can do SGT. We have a section for SDA segmentation. We have one knowledge article for Meraki adaptive policy and one for eBGP VXLAN as well, which was not part of this presentation. with that, I'll appreciate you filling the session eval. There is a lot of preparation going on with this, and please let me know what we can do better. Yes, sir?
So the policies are traditional protocol and port-based. Is there any support for next-gen firewall application-based at micro-segmentation level?
Yes. So here with the SGTs, what is happening, like you saw that in SD-WAN scenario, right? We want to make this SGT available everywhere. So today in firewall, generally it is different construct, but what if you have your SGTs available or identity available? That make it like really seamless and unique.
So the switch level, it can only by ACLs, can't inspect the packet.
Yeah, I have to research that, but at FMC can also pair with ICE and get all the SGT information. That is possible today. Yeah, maybe in future we'll add that. So with that, we are at the end of the presentation. Thank you for sticking with me. I know the last presentation is kind of like difficult to continue, but thank you so much. Yeah, if you have any questions, feel free to write that in Vivek's team room, and you can also reach me at amitsi4@cisco.com. Thank you.